today we're going to be going over some practice questions. We're going to start with the community tab. And then I got some questions that I wrote for you guys before I started this stream. So I'm kind of getting into, the practice question writing space, if you will. Who knows? Maybe I'll write a textbook. But nah, I'm not going to write a textbook. At least no time soon. So the first question, which is one of the questions that I wrote leading up to this stream, is which of the following tools allows users to view and control hardware attached to a device in Microsoft Windows? Is it Microsoft Management Console? Is it Download Manager? Is it Windows Update? Or is it Device Manager? So I wasn't able to trick any of you guys here. The 7 people that voted. Let's see, the 7 people that voted, all of you said, 100% of you said Device Manager. So I can't trick you guys. We'll see what it is over the course of, I guess, a week or so, because sometimes I'm surprised at some of your answers. Sometimes I put the most silliest answers, and I'm just teasing you guys. I'm not judging you or nothing, but some of you guys just be picking some obviously wrong answers, right? Obvious to me, but this is why we have these practice questions, right? So it's going to be the Device Manager. If you don't know what the Device Manager is, I'm going to show you right now. Honestly, I don't even know what the Download Manager is, so we can explore that as well. So let's check it out right now. Let's see. Okay, here we go. So let's see what the Device Manager is. This is the Device Manager, right? It shows you everything that's attached to your hardware, right? Your audio inputs and outputs, which is your microphone and your speaker, batteries. Let's see. Yeah, I don't know what this stuff is. Is it the battery inside the machine? Yeah. Bluetooth, cameras, which is my more than likely going to be my integrated camera. Yup. Computer. Huh. What do I have attached to it? Yeah, I have all sorts of stuff attached to this little laptop. But this is basically it. Network adapters. When you're consoling in with a Cisco console port, or when you're doing your Cisco lab, you can look through here to find out what COM port it is, and then you use PuTTY, and then you get in. This is really your bread and butter with regard to hardware troubleshooting. So that's pretty straightforward. Let's see what Microsoft Management Console is. Microsoft Management Console. It should be, let me see something. Run. I should be able to, well, let me see. gpedit.msc. Is that part of it? I think this is part of it. Not sure. Let me see. Yeah, this is it. So I don't have permission to see all of this stuff because this is a second account. But yeah, that's what the Microsoft Management Console is. Download Manager. Let's see what that is. Download Manager. I didn't know we had a Download Manager. I don't think we do. Windows Update. Yeah, to check for updates. But obviously it is the Device Manager, right? So let's get back to the questions, right? So close that laptop down real quick. The next question: what is a router commonly referred to? Now I'm smiling because I absolutely love networking. Hey, the channel's name is IPV Dre, so it is what it is. You're gonna be seeing a lot of networking related stuff because I'm trying to keep my networking skills sharp, and gain more networking skills. So we're going to continuously be going over a lot of networking concepts, and there's networking concepts on the A+. So it's a win-win, right? 64 votes. What is a router commonly referred to? Is it a default gateway, switch, hub, repeater, or bridge? Let's see the percentage. Let's see. 80% of you said default gateway. 14% of you said switch. 0% of you said hub. 2% of you said repeater. 5% of you said bridge. So, I actually just thought of another question going over this one. So, the answer is default gateway. So, we had an interesting question in here, and that makes for some great review, right? Someone asked, not just someone, Quick Strike 21 got the question right. And he said, router equal gateway to the internet. I'm 100% confident on this one. Yes, he's absolutely correct. And Joseph P.I. 4 I can't say that name. I don't know how to pronounce it. But he asked a great question. Why is it default though? What would be a non-default? Is it because there's no other option besides a router, making it default by default? I like that. I like the play on words. An access point doesn't have to be the router. Hotspot and tethering, for example. So what makes it default? I'm wondering. That's a great question. So first and foremost, it's a default router because that is the device, the router, and we're speaking on more of a TCP level there. So we can have an actual router that serves as our default router, which sends packets off subnet, meaning to another network, or we can use a layer 3 switch. A layer 3 switch is capable of layer 2 addressing and sending frames, and it's also capable of layer 3 functions such as routing and having a routing table, an RIB, etc., right? So a router is also referred to as a default gateway, but a layer 3 switch can also have routing capabilities, and it can also route packets off of the subnet, right? Or into another subnet, right? So what makes it default is the fact that the host will send packets to that device when it needs to communicate with another host in another subnet. The router will know what to do with that packet, because obviously if a host realizes that this IP address, for instance, say one host belongs to 192.168.1.0/24. That's the resident subnet that it belongs to, right? And it wants to send a packet to 192.168.2.1, for instance. The host is gonna realize that, oh, this packet is not in my subnet, so I'm gonna send it to the default gateway. So it'll send it to the default gateway. It'll send it to its router, right? So whereas if it was in the same subnet, it'll just send it straight to that host, right? So it sends it to the default gateway. The default gateway has a routing table which has a bunch of routes for these networks right here, right? So if you have a router that's connected to multiple subnets, for instance, maybe you have a managed switch with 5 VLANs with 5 different subnets, right? Remember, subnets are not a layer 3 concept. Subnets are a layer 3 concept. It is not a layer 2 concept. Let me just repeat that again. Subnetting and subnets are a layer 3 concept, and switching and VLANs are a layer 2 concept. So each VLAN is going to have a subnet embedded in it. So once it sends wants to send a packet to one of these 5 subnets, let's say that it's a 192.168.2.1 destination address, the router will know where to send that packet. It'll know how to forward it. It'll know its next hop. It'll know, where to send. And also, we need routers because layer 2 switches can't route packets between the VLANs on those switches. So it needs to send it to a default gateway or a router, because the default gateway also can be a layer 3 switch. So these devices, they know where to send these packets. That's why it is a default gateway. It's the default device that the host is sending the packet to in the event that it needs to communicate off subnet in another network somewhere, right? Now, routers also have default gateways, if you will, right? Because if a host wants to communicate with let's say a Google server, for instance, that exists somewhere out on the internet, the router won't have a route in its routing table. Or let's just talk about the default behavior of a router who doesn't have a route to some network, right? If a host wants to send a packet to a network that the router doesn't have a route for, and it doesn't have a default static route configured, it'll discard the packet. That is the default behavior. Now, if that same router has a default static route configured, it'll forward that packet to that default router, which has access to whichever network it needs to reach, i.e. the internet, right? And that packet will hop around the many different routers in the internet until it reaches its destination. So say, for example, again, that host wants to communicate with the Google server. It sends the packet to its default gateway. The router realizes it doesn't have a route matching that destination IP address, right? Because remember, the router looks at the destination IP address in the packet, and then it makes a routing decision based off of that IP address. There's other things that go into making that decision, but for sake of simplicity, it's looking at this packet and it's saying, okay, let's check my routing table. Oh no, I don't have a route for that, so I'm gonna send it to my default router, right? The default gateway has a default router that it sends packets to as well, right? So it sends it to this router that can be, or it is, an ASBR if you're using OSPF, and that means that it's an autonomous system boundary router, and it'll just simply forward the packet out to the internet, and it'll just, again, it'll bounce around until it reaches the destination. So I know that was long-winded and that might seem complicated, but that's just an introduction to routing and what routers do and why it's called the default router, right? Also remember, again, if you decide to go the networking path, which I hope you do, default gateways can also be SVIs, switch virtual interfaces, on layer 3 switches that have the capability of routing. And you can also activate dynamic routing protocols such as OSPF, EIGRP, ISIS, RIP. Don't use that. You don't need to use that. And yeah, so there's that. So to look at his question again, why is it default? We addressed that question. What would be non-default? I guess what would be non-default is the switch that's responsible or that's allowed to send packets between hosts in the same VLAN, right? So remember, layer 2 switches only deal with layer 2. So a host wants to send a packet to a host that exists on the same VLAN. It sends it to the switch sends it to the host that's on the same VLAN. I guess that would be non-default. But again, if it wants to communicate to a host in another VLAN, it has to go through its default gateway, right? Think of a router, again, it's I guess self-explanatory, but it's a gateway, right? It's allowing passage to other networks, right? Each network is essentially gated off by this router, right? So that's how you can really think about it. I'm glad that you asked that in-depth question, because it's also getting me to think about and to keep the networking stuff fresh in my mind, right? And then you said an access point doesn't have to be the router. That's true. Again, the access point, that if you have an access point and you have hosts that communicate on the same VLAN, that exists within the same VLAN, and you need to communicate, say you have hosts that exist within the same VLAN on the access point, that's kind of, the access point is kind of, I guess depending on how you set it up, but the access point is kind of acting like a switch in that way. Correct me if I'm wrong, but I believe the access point, because I'm not a wireless guy, but I believe that the access point is kind of acting like a switch in that way, right? But, and again, it depends on how you have the wireless network set up. A switch receives an unknown unicast frame on an interface in VLAN 30, meaning it doesn't have an entry in its CAN table for the destination MAC address. What happens next? The switch discards the frame. The switch returns the frame back out to the interface it came from. Switch floods the frame out all of the interfaces on the switch. The switch floods the frame out all ports in the respective VLAN. Okay, so let's read that again. A switch receives an unknown unicast frame, which is a frame that doesn't have an entry for that MAC address and its corresponding interface in its CAN table, right? For the destination MAC address, what happens next? So let's see what you guys said. So 29% of you said the switch discards the frame. 24% of you said the switch returns the frame back out the interface it came from. 5% said the switch floods the frame out all of the interfaces on the switch. And the switch floods the frame out of all ports in the respective VLAN. That's 43%. This was a nice question because I got sort of like a nice distribution of answers as far as the percentage goes. And the answer is the switch floods the frame out all ports in the respective VLAN. So this is one of those questions where you have to pay attention to the wording, right? A switch receives an unknown unicast frame on an interface in VLAN 30. So the rule is that each VLAN is essentially its own broadcast domain. So if you keep making these VLANs, so you got VLAN 10, 20, 30, each one is its own broadcast domain, meaning that when you have a host that wants to, I guess, talk to all hosts, it has to, it can only communicate with those hosts in that VLAN, right? It can't cross over and communicate with other hosts and all of that stuff. It has to only, those broadcasts are only restricted to that VLAN, right? I believe that's the proper way to phrase it and word it, right? So in the event that a broadcast is being propagated out of a specific interface, it's going to coincide within that VLAN, right? So that's where this question kind of like, you can see the clue is like right here, right? So if a host comes onto the network via VLAN 30 and the switch receives some sort of communication to that new host, then the switch is like, okay, well, I don't, and that host, again, the key thing here too is that host that just came onto the network didn't generate any traffic yet, right? So it doesn't know what its MAC address is. And we know that switches learn MAC addresses by MAC addresses of the devices by taking note of the port and the MAC address, right? So taking note of the port that frame came through with the source MAC address. It learns it and it plugs it into the CAM table. So now when another host wants to communicate with that host, the switch will know where to propagate that message out of. So that's what happens with, that's, I guess you can say, the exposition behind an unknown unicast frame. You can assume that that host that it wants to communicate to hasn't generated any traffic, and the switch hasn't learned its MAC address yet, right? And it's not in the CAM table. So, but the thing is that interface, all of these, that interface, right? That the new host onboarded to exists in VLAN 30 as per switch configuration, switch port access VLAN 30, right? So that host just onboarded into that VLAN, right? Let's hope that it's a legitimate, it's not a rogue device or an attacker. And another host wants to communicate with that switch for some reason, that device for some reason, right? So it tries to communicate with it, and the switch doesn't know who it belongs to or what port it needs to forward out of. So it forwards it out of it floods the frame out of all ports in the respective VLAN, right? So that's the answer. If this one is pretty close, right? That one is pretty close, and only 5%, because that one's kind of like a red herring. This answer right here, the switch floods the frame out of all the interfaces on the switch. That was kind of a red herring because of the simple fact that we have multiple VLANs, right? And since we have multiple VLANs, it needs to it's gonna flood it out of all of the ports in the respective VLAN, which is VLAN 30. If it was only VLAN 1, which we shouldn't even be using, we need to change that at any given moment. If it was only VLAN 1, or if it's only VLAN 20, then the switch will flood the frame out of the interface, out of all the interfaces on the switch, right? So again, if all interfaces existed in one VLAN, then it would have flooded out of all the interfaces on the switch. Pretty much that's how that goes, right? So I hope I didn't bog you guys down with too much details, but I figured that'd be a great question to post, get you guys thinking a little bit more, and get me thinking too. Again, refreshing my memory with all of these concepts, because by no means am I perfect. I'm not perfect. And this is the whole idea behind, when you get your certification, the work doesn't stop. The work keeps on going. You still have to keep your knowledge fresh, and you have to lab, right? So we got some more practice questions here. We did this one already, so we don't need to go over that again. We got 3 more. Which of the following is the third step in the troubleshooting methodology? So what is the troubleshooting methodology, right? It's identify the problem, establish a theory of probable cause or guess, test the theory to determine the cause, establish a plan of action to resolve the problem and implement the solution, verify full system functionality, and if applicable, implement preventative measures. So that's a mouthful. Document findings, actions, and outcomes. So obviously it's the third one, right? Which is to test the theory to determine the cause, which is E right here. Can I highlight it? Or can I bold it? Let's see if I'm just gonna bold it. See if I can bold the whole thing. Nope. Just bold it. Yeah, bold the whole thing. Boom. So that one is straightforward. All you need to do is memorize that troubleshooting methodology. You can use silly mnemonics like I'm going to what is the mnemonics? Let me not even play myself by trying to make up something that absolutely makes no sense. I have it in my notes. I'm going to Poland via Denmark. I believe somebody commented that. Or I'm going to Poland vice Denmark. I don't know. I copied that off of some Reddit forum when I was studying for the A+. Let's see how far that goes back. No, I edited this note, so I can't even see the date. So, moving on. Oh, more networking questions. You have just set up a network that will use the TCP/IP protocol, and you want client computers inside clients with private IPv4 addresses to be able to reach the internet with a public IP address. Which of the following would you need to configure it? So I did this on my last stream, and I had since unpublished that stream, but I do have a video on NAT coming up. So you'll get more familiar with the basics of NAT because I talk about it in that video. Sort of as like a refresher for myself. Again, keep things fresh, keep these skills fresh, and to kind of like introduce, I wanted to introduce NAT in that video because I was doing BGP at the same time, and that lab, I wanted to make that lab as conceptually realistic as possible. And I was using BGP and configuring BGP, connecting these autonomous systems, but they all had private IP addresses. So I wanted to make the scenario a little bit more real, and I started talking about NAT, right? So obviously the answer here is gonna be NAT. So NAT allows for clients with a private IP address to communicate out on the internet with a public IP address. NAT stands for Network Address Translation. I'm wondering why it's kind of blurry. NAT stands for Network Address Translation, and it's source NAT, by the way. And it's all in the phrasing. It translates IP addresses on the inside network to a public IP address to communicate into the outside network, whether it's different branch sites in an organization or onto the internet. And I believe in branch sites. In branch sites, you can have branch sites that are connected together, and I guess you don't have to use NAT on the inside of that network, that whole network with branch sites and all that stuff. You can have the ASBR router be the NAT router, probably, I think. So just a little thought with that. And also that all happens, at least to my book knowledge, via a VPN, right? You can communicate with a virtual private network inside of that organization. And I don't think you would need NAT at that point. Maybe not. I still have more to learn with regard to advanced networking concepts, such as connecting those organizations that are geographically separate, right? Fun. That should be more CCNP stuff. Okay, the next question, more networking. Which of the following IP addresses would be valid for a DNS server out on the internet? So remember, private IP addresses are not routable. They cannot communicate out on the internet in of themselves. They have to be translated to public IP addresses. So that's the first thing you can think of, right? So you know that it's not going to be a private IP address. And it has to be a public IP address because the DNS server is a public device, typically. More than likely is going to be in the DMZ, demilitarized zone, of some network that's offering that DNS server, right? So you have Cloudflare, you have Google, And this device has to be publicly accessible. Now, of course, you can use port forwarding, which is more than likely what's happening with being able to reach that DNS server, but it needs to have a public IP address, right? So which one of these are public IP addresses? And I wrote this question specifically to kind of trip you up. I'm gonna post this on my community tab maybe later next week and see how many people get this question, right? So we know that in request for comments defines private IP address blocks that allow for the allocation of private IP addresses within the private network, right? So those IP addresses are separated into class A, B, and C, right? So we have class A, which is the whole 10.0.0.0 network, right? And then you got class B, which is 172.16.0.0, and then you got 172.31.255.255, and then you got class C, 192.168.0.0 to 192.168.255.255. Now, knowing that, you have to pick out which one of these IP addresses are not within that private IP address block, right? Those IP address blocks in request for comments 1918. And that's going to be C. Why am I dragging? What was that? Why am I dragging it? That wasn't supposed to be. Oh boy. Anyway, it was supposed to be screwed up. 1.2, right? So it's supposed to be this answer. This is the answer right here, right? So it's going to be 192.0.1.2. And why is that? Because this is it. Although it looks like it could be within the private IP address block, it's not. And the private IP address block is this 192.168.0.0. Or you could just put a /24, which means this goes to 192.168.168.255.255. Cool, right? That is outside this range. It's well outside that range, and that makes it a public IP address. I think I used that IP address in a previous video, by the way. So that's pretty much it for the practice questions. I hope that helps you out, and I hope that, help you study for your upcoming A+ certification exams.